Let's take a look at an absolute extrema application. This one is maximizing revenue given price, but price is not in the usual form. So we look at this example where the price of the particular unit, X units sold, price is buried in there. This is a lot of information. We're going to read through this 3 times. The first time, we're going to put ourselves in the neighborhood. The second time, and you should have your pencil down for the first time. The second time, what are they asking you to find? Have you tried to find it before? Is it something similar you can do? And then the third time, you're going to actually write down, pick up the pencil, write down what you're trying to find and any information that they give you. So let's take another look. Pause the video to read through this on your first time and then your second time. So the third time you go through, you know, X is the number of units, P is the price in dollars, and you're going to write this equation down. That's the number of units sold with price embedded in there. We need to round our answer to the nearest penny or unit. And we're asked to do 3 things. Maximize revenue. We've done that before, and we've done examples where you have to find the price to do that maximum. So we're going to need to create a revenue function because we don't have one. Once we find out that max, then we can find how many units have to be sold at the price and what the max revenue is. So we gather our information. We have X is the number of units sold, P is the price in dollars, P is embedded inside here, and we need to find the revenue function. And to do that, we have to take that function of X, and then let's go ahead and solve that for P. We could multiply X times price, but we don't have price. So this is quantity times price. So we know we need X times price, but our price again is stuck inside here. So let's go ahead and square both sides of this equation. And when we do that, we get X squared is equal to 100 minus P. Let's add P to both sides and subtract the X squared from both sides. There's our price function. So we get to put that in here and then go ahead and distribute. We get 100x minus x cubed for the price. And that is then the revenue. So price here, revenue here. That gives us all our information all together now. X is the number of units sold. P is the price, don't forget in dollars. X, that's the equation that they gave us, and we had to go ahead and find the price function by solving that for P. And then we went ahead, quantity times price is equal to revenue. So these are the functions and equations that we're going to need to use. The first question we need to answer is maximize the revenue. To do that, we need to find the first derivative. And then we're going to search for critical values. And once we have the critical values, we have to see how many we have. So let's take the derivative of this revenue function. That gives us 100 minus 3x squared. To find the critical values, you set that equal to 0. Add the 3x squared to both sides. Divide both sides by 3. Sure, it's ugly, that's okay. And take the square root of both sides, plus or minus, don't forget that. X is equal to plus square root of 100 over 3 and minus the square root of 100 over 3. My argument is that if X is equal to quantity, you can't have a negative quantity. So you're going to toss this guy out. And when you do that, we can go ahead and simplify our X value because this is really square root of 100 over square root of 3. We get 10 over root 3. And that is a unique critical value for us across all X values in that function, which means we can use our second derivative definition and concavity to figure out whether we have a maximum or not. So let's go ahead and take the second derivative. We are using this guy here, first derivative, to do that. Derivative of 100 is 0. Derivative of negative 3x squared is negative 6x. And that's not always the same value. So we're going to have to substitute in our 10 over root 3 into that second derivative. Negative 6 times 10 over root 3. And we don't care what number that is. What we do care about is that is less than 0 for all real numbers. Less than 0 means that it's concave down, and we have a max at 10 over root 3. We can then go ahead and find the price because we're looking for price per unit that maximizes that revenue. So we know we have a maximum there. The price, our function is 100 minus x squared, and that came from up here, our collection of functions. And so substitute that in. The price evaluated at 10 root 3 over root 3, we get 100 minus 10 over root 3 quantity squared. You can use your calculator for that if you want. You can simplify a little bit first. 10 squared is 100, root 3 squared is 3. So we're getting 66.6 repeating. That means we need to, sorry, wrong buttons. We need to charge about 66, 67, you got to round to the nearest penny per unit to maximize revenue. And that's the answer to the first part of the question. So we've got this critical value of 10 over root 3. We showed because it's absolute extrema, we can check concavity. We know it's facing down, so that means we do definitely have a max, and then go ahead and find that price. The next question is how many units will be sold at this price, and how many units, that's actually, I'll write this down, that's the critical value that we found. And so x is equal to 10 over root 3, which is about, we have to round to the nearest unit, about 6 units. So we will, don't forget your sentence answer, we will sell about 6 units at that price. The final question is, what is that maximum revenue? We know that our critical value that we're working with is this guy. That's a 10. 10 over root 3. And so to find the max revenue, we have to take that and substitute it back here into our revenue function. 10 over root 3 is going to be 100 times 10 over root 3 minus 10 over root 3 cubed. And use your calculator, and you find that it's about 384.90. Don't forget to give your final answer. The maximum revenue is $384.90 and occurs when 10 over root 3, or about 6 units, are sold, and don't forget the price, at $66.67 each. All of that is your final answer. And so that's it. I recommend, if this is still a little confusing, go back through and watch it again, or go watch some of the other Absolute Extrema applications on the channel. Hope you're having a great day.